let's talk about graphing systems of linear inequalities. Now, previously we've talked about graphing a linear inequality on its own. Today we're going to talk about systems, meaning more than one inequality is going to be given at a time. So before we get into our examples, there's only 2 today, let's look over our important facts that we need to memorize and own. If y is greater than, you're going to shade above and it will be a dashed line. If y is less than, you will shade below the line and it will be dashed. If y is greater than or equal to, you're going to shade above the line and it should be solid because that line will be included since it's equal to. And y is less than or equal to, you should shade below and that line should also be solid. So we have this information here. Let's take it and let's actually look at a problem. So we have y is less than negative x plus 3. This first inequality right here. It's already in slope-intercept form, which makes it very easy to graph. So let's go ahead and graph. What would be your y-intercept of the top inequality? 3. Let's go plot that point at 3. And our slope is negative, you're right, negative 1 over 1. So that means we're going to go down 1 and to the right 1. Down 1 to the right 1. Down 1 to the right. And I'm going to extend my line as far as possible. And in the other direction, I'm going to go backwards. So I'm going to go up and to the left. So it's fully extended. This is the direction that my line should take. But let's look at our inequality symbol. It says y is less than. So there's no equal to sign underneath. That tells me that I have to represent this line with a dashed line. Also, let's look at the inequality. It says y is less than. So am I going to shade above the line or below if y is less than? You're right, below. So we're going to go below this blue line. If you've got colored pencils, it would be fantastic. You'll see why shortly. Okay, so we're below this blue line. But we have another inequality that we have to deal with. The bottom, which is negative 2x plus 4y is greater than or equal to 0. Now this is set up in standard form, which is easy to graph using your x and y intercept, but let's practice getting y by itself. So how would we do that? We're going to add 2x to the other side. So I have 4y is greater than or equal to 2x plus 0. Still don't have y by itself, so to get y on its own, I'm going to divide every little thing by 4 and clean this up. Y is greater than or equal to 1/2 x plus 0. Now notice that I divided by a positive 4, and there's a rule that when you divide with a negative number, that you have to flip that inequality sign. So that rule still stands because we are dealing with inequalities. So look out for division with negative numbers and flipping the inequality because that will change the shading. Anyway, let's go with this. Y is greater than or equal to 1/2 x plus 0. The y-intercept is 0. My slope is 1/2, so I'm going to go up 1 over 2. Up 1 to the right, 2. Up 1 to the right, 2. And continue. Going to go backwards to extend my line on this side. Down 1 to the left, 2. Down 1 to the left, 2. So this is the direction of our red inequality. Let's look at the inequality symbol. This tells a lot. We have y is greater than or equal to. There's an equal to. So I want to include all points on this line. So I need to make it solid. Let's look back at the inequality again. Y is greater than or equal to greater. So we have to decide where are we going to shade. Y is greater. You would shade above this line. Above this line. Which looks a little something like this. Now, we've talked about before with inequalities that the answer or the solution to the problem is the shaded region. The more inequalities that you put out onto a graph paper, your region becomes constricted. So where is our solution for this system of linear inequality? We want to look to see where the two colors cross each other. That's why I said if you had colored pencils, you can perfectly see where the two colors are crisscrossing each other. And I think you would tell me that it would be this area here, this V, this slice of the graph is where the green and the yellow cross each other. So I'm going to darken it in. I'm going to use a different color here to illustrate this is the important region. Don't really care about this down here, nor this over here. I'm wanting to know what is the solution that satisfies both linear inequalities, not just the red and not just the blue, but both of them. And it would be this red area here. So I'm looking for the darkened section. What if I ask you to go backwards from that? What if I give you the picture and the solution set, and I want you to write a system of linear inequalities for the shaded region that's represented? Let's do that. Let's take this green line, and I'm going to work with it in green. It's a horizontal line, so who remembers how we would represent a horizontal line as an equation? If you said y equals something, that is absolutely correct. So where does this cross on the y-axis? I think we would all say that it crosses at 4. So tentatively, we would be looking at this equation right here, y equals 4. Well, we know we're not dealing with equations because we have a shaded region. So let's go ahead and clear out that equal sign because we do have an inequality. Y is something. Let's figure that out. Let's look at this line. Is it dashed or is it solid? The green line. It is dashed. So that means we're either going to be looking at less than or greater than because both of these symbols do not have an equal to underneath. Let's also look at this. Where is it shaded? That's going to tell us which inequality to use for sure. Based on this green line, is the shaded region below the green line or is the shaded region above the green line? I think you would say below. So what represents shaded below and dashed is the less than inequality. Y is less than 4. We've just taken care of that green line. Let's talk about the blue. The blue line here. All right, what do we know? Well, I see that it crosses the y-axis at 2. So I have a y-intercept of positive 2. What about my slope? Let's see. I would say that it crossed right here pretty good. So let's go from this point to this point. How would we get there? Let's go down 1 and to the right 2. My slope is down 1 to the right 2. So I'm looking at a negative 1/2 x plus 2. So we're putting this in slope intercept form. Depending upon that line, is all about what this inequality is going to be. How are we going to represent what is happening with this blue line? Well, let's talk about it. Is it dashed or is it solid? It's a solid line. So we're looking at less than or equal to or greater than or equal to. Both of these because we have to have an equal to sign underneath because it is a solid line. We are including every point on this line. Now let's look at the shading. Is it shaded below the blue line or is the shading above the blue line? And I think you guys would say and agree with me that it is definitely shaded below the blue line. So below is less than. So we have a less than or equal to symbol here. This is the system of inequalities represented by this picture. Y is less than 4 and y is less than or equal to negative 1/2 x plus 2. So you guys come on to class, we'll practice more problems and we'll go from there.